A couple of more things to think about, Lincoln. You don't want to go anywhere near your Tesla coil with this probe. I would suggest a small coil of wire, one end hooked to the probe, the other end hooked to the ground, and sort of wave it in the vicinity of whatever you want to look at on the oscilloscope. The voltages you're going to encounter on the Tesla coil are going to damage the oscilloscope. So just pick them up with an air coil. Of course, scrape the insulation off both ends. I didn't do that. I'm also going to include this function generator. Now, it's just a signal generator. I think they call it a function generator because it has the ability to output a square wave, a triangular wave, or a sine wave. This will produce signals with a frequency range up to 2 megahertz. There's a there's a coarse dial and a fine dial. This adjusts the frequency. You'll see I'm about halfway. You can see the white line. And I'm about 991 hertz. I've got the 1 kilohertz button depressed. So in theory, this should go to 2,000 hertz. I'm keep going backwards here. This should go to 2,000 hertz, twice this number, and it should go down to like 100 hertz. In the middle, it's about 1 megahertz. At this end, it's around 2 megahertz. So you get a 10 to 1 range here, with this in the middle being the nominal frequency shown. This power button, this is the output. Now to connect this to your oscilloscope, it's like push and turn thing again. This is called a BNC connector or a bayoneted end cable connector, but everybody calls it a BNC. I included a double-ended BNC cord that you can connect from here to your oscilloscope. If I hook this output, not this one or this one, to the oscilloscope, you'll look and see that the oscilloscope shows a sine wave, a frequency 1.007. This says 1.008. But remember, this is rounding up. If I press this button, which will create a triangular wave, you see it produces a series of triangles. If I push this button, it'll produce a square wave. I can vary the amplitude with this knob. I can vary the frequency with this knob. I can distort the shape. In the case of a square wave, it'll get longer. In the case of a triangular wave, it gets tilted, see that? In the case of a sine wave, it skews it around. When this knob is the whole way over in this direction, it's calibrated, which means the sine wave, the triangle wave, and the square wave are perfect. So this will give you something to learn with on the oscilloscope. Now my oscilloscope has a built-in frequency indicator. Yours does not. So this inverts the output signal. Normally you want to leave all of these pushed in. I can't demonstrate this on your oscilloscope because it's already boxed up. When you unpack it, make sure you get the leads out, the cables, the probes. They're in a paper envelope with the packing material. The last thing I'm going to send you is this multimeter. Your dad can show you how to operate it. I think the batteries are still good. Yeah, there they go. The manual's still in here. And there's a probe to measure temperature.